When we look at a missile, we see a sleek, metallic cylinder. It seems simple, almost singular, as if it came from one building, one assembly line, one place. But the truth is far larger and far more global. A modern missile is not one machine, it is the final convergence of entire industries: mining, chemistry, electronics, aerospace. More than 5,000 individual parts come together from hundreds of suppliers scattered across continents. And to understand its story, we must begin not in a factory, but deep in the earth itself. Every missile begins as geology: rocks, minerals, dust pulled from ancient layers of the earth. The airframe's strength comes from metals like aluminum and titanium, materials born from ores such as bauxite and rutile. These stones travel thousands of miles before they ever become the smooth, polished surfaces we see. Rare earth elements are among the most strategically sensitive. A missile's eye, its seeker, relies on them. They may start in one hemisphere, be refined in another, shipped to a third, and finally transformed into components smaller than a grain of sand. Even energetic materials, shaped by complex chemical industries, depend on delicate supply chains. Their availability can determine how fast or how slowly nations can produce advanced systems. Once raw materials leave the ground, they enter a vast, interconnected web. Missile manufacturers depend on an ecosystem of suppliers: chip makers, sensor specialists, optics firms, composite fabricators. A single guidance component may include silicon processed in one country, electronics assembled in another, precision sensors built somewhere else entirely. Major programs can involve dozens of subcontractors, each delivering one carefully engineered piece of the overall puzzle. Logistics systems coordinate thousands of moving parts, predicting delays, routing shipments, and balancing production schedules. The factory becomes a global command center long before it becomes a place of assembly. The final assembly facility, the all-up-round plant, is a place of precision. Clean rooms protect sensitive optics. Robotic systems move large sections with silent, deliberate motion, aligning components with microscopic accuracy. These factories are designed digitally before construction begins. Engineers step into virtual reality, simulating the workflow, checking clearances, ensuring every motion is possible and safe. Assembly blends human expertise, robotic precision, and strict safety protocols. Thousands of global parts finally become one. Before shipment, components undergo environmental testing: extreme heat, extreme cold, intense vibration. Each component has a digital record, documenting origin, performance, and inspection. If a problem ever occurs, engineers can trace its history back through time, piece by piece, batch by batch. This traceability ensures accountability and precision. At last, after years of supply chains, months of assembly, days of testing, the missile is sealed into its container. But its story is not just about engineering, it is about the resilience of entire supply networks. Shortages in raw elements, even basic ones, can slow production dramatically. A missile factory is more than a building. It is the expression of a nation's industrial strength, its access to resources, and its ability to coordinate global complexity. From minerals in the ground to sensors at the tip, This is the journey of a modern weapon.